Hello friends, in our previous video we have seen the load and store instructions of 80387. Different types of instructions were there. Now our today's topic is trigonometric and transcendental group of instructions. This is again important topic as your exam point of view. These all transcendental instructions use stack top or stack top 1 as their operands, and the result is stored back onto the stack. Again, likewise, previous instructions, here stack plays the important role. The result is stored onto the stack. There are total 8 groups of trigonometric and transcendental group of instructions. Here we can see the first is f2xm1, that is 2 raised to the x power 1. Second group is fyl2xp1, that is y into log to the base 2 x plus 1. Next instruction is fyl2x, that is log y into log x to the base 2. Next is your fp tan instruction, that is partial tangent instruction, and then fp a tan instruction, that is partial act tangent instruction. Then f cos, that is cosine instruction. Then f sin means sine instruction. F sin cos, that is sine cos instruction. Now we'll see every instruction one by one. The first one is f2xm1, that is 2 raised to the x power 1. This instruction calculates the 2 raised to the x power 1. This instruction calculates the st of 0 function, that is stack top of 0 function, where x is equal to top of the stack 2 raised to the x power 1. This is mathematical concept actually. You just have to remember it. And the syntax for this instruction is simply f2xm1 with no operand. An example is only f2xm1 with no operand. And the exception flag generated with this instruction, that is null. No flag is generated by this instruction. Second type of instruction is fyl2xp1, that means y into log to the base 2 x plus 1. This instruction gets the x value from the top of the stack, that means from the TOS and ST. Y value from the ST of 1, ST just below the ST of 0, and pops the stack and return the result of calculation to the top of the stack register, that is ST. Now the syntax for this is shown here. Again fyl2xp1 as it is instruction with no operand, and the example for this is same with no operand. And the flag generated for this instruction is parity flag. Next is your fyl2x instruction, that is y into log to the base 2 x. This instruction takes the value of x from top of the stack, that is from ST, and value for y from the ST of 1. The instruction next pops the stack and store the calculator result back onto the top of the stack, that is ST, stack top. Here we can see the syntax for this is fyl2x with no operand, and the example for this, the flag generated for this exception is parity flag. The next type of instruction is FP10, that is partial tangent instruction. It calculates the tan of an angle. This instruction computes the y divided by x is equal to tan theta of an angle, where the range for the theta is greater than 0 and less than pi by 4 and is taken from the top of the stack. The value of this is taken from the top of the stack. After completion, y replaces theta on the stack. Again, y puts the theta onto the stack and x is pushed to become new top of the stack. Now the syntax for this FP10 is given here. Simply FP10 with no operand, and example is like this: FP10. The exception flags generated for this instruction are interrupt flag and parity flag. Now moving to the next instruction, that is FPA10. That means partial arc tangent. This partial arc tangent calculates arc tan of an function. This instruction pops the x value from current top of the stack and pop stack a second time. Takes the now current top of the stack for y value. Again this calculates the value y by x and returns result to the top of the stack register. The range for this is given here. Syntax for this arc tangent is like this: FPATAN with no operand, and the example is like this: FPATAN. Exception flags for this: user flag and the parity flag. Next is your FCOS, that is cosine instruction. This instruction basically calculates the cosine of an angle. This instruction calculates the cosine of an angle of top of the stack, the number of top of the stack. The angle is in radians. Upon the completion, the result is placed on top of the stack again. The syntax for this is given here: FCOS, that is F cosine, and the example will be like this only: FCOS. Exception flags generated for this are parity flag, interrupt flag and the direction flag. Next type of instruction for this is F-sine, that is sine. This F-sine calculates a sine of an angle in radians. This F-sine calculates the sine of an angle expressed in radians at the top of the stack, and the result is placed back onto the top of the stack. The syntax for this is shown here: simply F-sine, F-sine, and the exception flags for this F-sine are parity flag, direction flag and interrupt flag. And the last one is your F-sine cos, that is sine cos instruction. This instruction calculates both the sine and cosine of an angle expressed in radians again. Those are at the top of the stack. The result is placed on the top of the stack. The syntax for this is simply F sine cos. And the exception flags generated are parity flag, direction flag and interrupt flag. In this way, we have completed your 6th unit. Thank you.